Right, next question. Jeanette is trying to find the intersection point of these two equations listed below. She has decided to use substitution method to find the point of intersection, and her plan is to solve the first equation for y and then to substitute the result into the second equation. So use Jeanette's idea to solve the system. All right, so we want to take that first equation, 2x plus 3y equals negative 2. Because remember, to use substitution method, we need it to be in y equals blah, blah, blah form. So right now, there's nothing I can substitute, so that's not going to work very well. So we got to do that. So in order to get y by itself, we need to move the negative 2x over. Subtract 2x over there. 2x is here, will cancel, so I'm left with 3y on the left side. And on the right side, we've got a negative 2 and a negative 2x. Can you combine a non-x with an x? No, you can't. So it's going to be negative 2x minus 2. And then my last thing we got to do is we've got 3 times y, so I want to divide by 3. I want to do to one side, I do to the other. So then I get y is equal to negative, and if I want to break this up, it'll probably be easier, so let's do it. Negative 2/3 x minus 2/3. All right, so we got some fractions, not the most fun thing that we're going to be able to do, but let's see if we can do that. So I want to take, now that I know what y equals, I can take that and I can substitute it into this equation. So now that I know what y is, I can substitute that in for y. So let's write the second equation. 5x minus 3y is equal to 16. Again, I want to rewrite it, 5x minus 3, but instead of writing y, I want to write what y is equal to, which is negative 2/3 x minus 2/3, and then set that equal to 16. Equal to 16. Very nice. Let me erase that, make sure it's all the same color. So equal to 16. All right, so let's distribute. So we've got 5x, and I want to distribute the negative 3 to the negative 2/3, and note that the negatives are going to cancel there, and a negative times a negative is a positive, so that's going to leave me with a positive 2x. And then let's distribute here. Once again, the 3's cancel. A negative times a negative is a positive, so once again we're going to have a positive, and I would just be left with 2 equals 16. Okay, distributing is a little bit tough, especially with fractions, so if you need help reviewing that, we can work on that as well. So combining like terms, 5x plus 2x is going to give me 7x, plus 2 is equal to 16. Subtract 2 from both sides. I get 7x is equal to 14, and even though I had some bad fractions halfway in there, I divide by 7 on both sides, and I get a nice answer of x equals 2. So again, once we find one of the answers, we got to plug it in for the other one. When we plug it in, we want to try and make sure that we plug it into the original equation, because if by chance we made a mistake going from that original equation down to there, by plugging it into the original one, it's going to help us avoid any of those mistakes. So 2x plus 3y is equal to negative 2. That's that top equation. Remember, now we know what x is, so I can plug it in. So 2 times 2 plus 3y equals negative 2. 2 times 2 is 4, so 4 plus 3y equals a negative 2. I can subtract 4 from both sides, get 3y is equal to, well, negative 2 minus 4, give me negative 6, divide by 3, get y is equal to 6 divided by 3 is 2, and a negative divided by a positive is a negative, so y equals negative 2. And last step to find that point of intersection, we're going to write our answer as a coordinate point. So remember x comma y. So this x is going to be 2, and the y is going to be negative 2 for my final answer. All right. So you may or may not have found that substitution worked really nicely. Okay. It did work. It did get us an answer. But if you look at all of the work we had to do to get that answer, that was quite a bit. Okay. So if you take a look at the next problem, you'll see that there's another way to do this that is a little bit easier to do. So we call this the elimination method. So you see we have the same equation. We've got that first equation and the second equation. And what we're going to do is we're going to just take the pieces and add them together. So we've got 2x right there, and we're just going to add them together. So 2x, let me write these over here. So we've got 2x plus 3y is equal to -2. And then our second equation is going to be 5x minus 3y is equal to a 16. And so the elimination method just states that I'm going to add these two equations together. So 2x plus 5x is going to combine to get me 7x. A positive 3y and a negative 3y is going to combine to get, oh wait, those cancel out, or they eliminate, hence the name of the elimination method. And then that's going to equal -2 plus 16 is going to equal 14. So now that we've eliminated the y's, I have a nice easy equation of 7x equals 14. Remember, saying plus 0y, there's no reason to say that. So we can do one last step, solve for x, which means we're dividing by 7, and get x equals 2, which if we look back, yeah, x did equal 2. So you can see you can either do all of this work to solve for x and get an answer, or you can just do this quick elimination method to get the answer. Once again, we do still need to find y, so once I've got it, I've got to plug it in. And we can plug it into either equation, it doesn't matter. Last equation I plugged it into the blue one, so let's just plug it into the red one to see how that works out for us this time. So 5 times 2 minus 3y is equal to 16. 5 times 2 is going to be 10 minus 3y equals 16. I'm going to subtract 10 from both sides since that 10 is positive. Get a -3y equals 6. Divide by -3, divide by -3, and get y equals -2. Once again, didn't matter which one we plugged it into, and didn't matter which method, we got x equals 2 and y equals -2 as our answer. And I'll write that as a coordinate point, 2, -2. All right, there are 4 more problems on the next page, so go ahead and give those a try with the other video.